Okay, I'm going to be going through the first of the pure papers from A-Level Maths. This is the Year 13 mock from March 2022. Question 1. In an arithmetic series, the first term is 16, the 21st term is 24. Find the common difference of the series. Well, the first term is 16, so A is 16, that's straightforward. B, the 21st term is 24, so the 21st term is A plus 20 times D, because it's n minus 1, and that equals 24. So therefore D is equal to 24 minus A, which is 16, divided by 20. So that's going to be 8/20ths, which is 4/10 or 2/5. So 2/5 or 0.4. That's not part B. It's part B. Hence, find the sum of the first 500 terms of the series. So, what we do here, about the formula book. So we're looking for A-Level Maths Pure, which is page 5. And arithmetic series, here we have the sum of the first n terms. And we're told it's a half n into 2a plus n minus 1 times d. So it's just a formula plug for this one. So it was Sn is equal to half n into 2a plus n minus 1 times the common difference. We want the sum of the first 500 terms, so n is 500. We know that a is 16, n is 500, so that's 499 there, times d, which we know is 0.4. And just pop that in the form in the calculator. So we're going to get 250 plus, times 32 plus 499 times 0.4. 57,900. That's the answer. Okay. Question 2. A curve C has this equation. Find dy by dx and d2y dx squared. Okay. A part I, dy by dx, so x squared differentiates to 2x. 2x differentiates to minus 2. And the minus 24 root x, well, I'm going to write that as minus 24x to the half. And just apply the same power rule, okay? Multiply by the power, subtract 1 from the power. So that's going to be minus 12x to the minus a half. And then y double primed, that's going to go to 2, that disappears. And now we're going to times by the minus a half, that becomes plus 6x to the minus 3 on 2. Part B. Verify that C has a stationary point when x is 4. Okay, so that occurs when dy by dx is 0. Now, because it says the word verify, we can use this answer in here. So y primed at the point when x is 4 is equal to 8 minus 2 minus 12 times 4 to the minus a half. Okay, we're looking for a 0 answer here. So that's 8 minus 2 minus 12 times a half. Okay, 4 to the minus a half is a half. So that equals 8 minus 2 minus 6, which is 0. Therefore, C is stationary at x equals 4. Part C. Determine the nature of the stationary point, giving a reason for your answer. So you can either gradient profile, which means you move a little bit to the left of 4 and a little bit to the right of 4 and have a look at the gradients there, or we can use the second derivative. As we've already calculated the second derivative, it makes sense to use that. So y double primed at the point x equals 4. I don't actually care what number it is, what I care about is the sign of it. And I've got 2 plus 6 times, well, that's going to be a positive number because I'm plugging x as 4. So that's going to be greater than 0. You could put a numerical value to that, of course. So 2 plus 6 times 4 to the power of minus 1.5, that's 2.75. Okay. Therefore, okay, it's a maximum, it's a positive, so therefore it's a minimum because the gradient is increasing. That's what that says. The gradient is increasing, so for it to have a stationary gradient, it must be going from a negative gradient to a positive gradient for it to be increasing. Okay, so therefore it's a minimum. Okay. And if you have a graphical calculator, you can, of course, just check that answer. Okay, graph mode is number 5. Clear what's in there. And the curve was x squared minus 2x minus 24 root x. Change the V window. Let's go from minus 2 to 10. Let's have a look. Oh, no, not gone down far enough. Oh, that's quite far down. There we go. It's a minimum. So we can see that here it is starting to go back up again, and here the gradient is negative. So it's definitely a minimum when x is positive 4. Question 3. Figure 1 shows a sector AOB of a circle with centre O and radius R. The angle OAB is theta radians, and the area of the sector AOB is 11 centimetres squared. Given that the perimeter of the sector is 4 times the length of the arc, AB, find the exact value of R. Okay, so get some algebra in there. We know that the area of this is 11. Now the area is R squared theta. And we know that this is 11. Okay, so that gives us one equation. So therefore, R squared theta must equal 22. And we also know that the perimeter of the sector is 4 times the arc AB. So let's call this arc length X, which is just R theta, actually. Perimeter of the sector, so we're going to have R theta plus 2R, that's the perimeter of the sector, and that's 4 times the arc length AB, which is R theta. So the perimeter is 4 times the arc length, and that gives us another equation in terms of R and theta. We want the exact value of R, so I'm going to eliminate theta from that. So I'm going to say that theta is the same as 22 over R squared, and then I'm going to plug that into there. So that's going to give me 22 on R plus 2R equals 88 on R. Okay, the R's here have cancelled with one of the R's on the bottom to give us just an R. Subtract 22 of them, so that's 2R is equal to 66 over R. Times by R, divided by 2, I get R squared is 33. Therefore, R is the square root of 33. And we only want the positive root because the radius is a positive number. So we want the square root of 33, which is obviously root 33, which is about 5.7. No, find the exact value of R. No, we leave it as root 33. Just check the answer on that in the mark scheme. Yep, root 33. Question 4. In the binomial expansion of a plus 2x to the power 7, where a is a constant, the coefficient of x to the 4 is 15,120. Find the value of a. So we want just the coefficient of x to the power 4. So that's 2x to the power 4, and we're going to have a cubed. Okay, so we want 7 terms altogether. The number of ways to do that is 7 choose 4 or 7 choose 3. It's the same number. And we know that this is going to be 15,120 x to the 4. Okay. So 74, again, that could be calculated on the calculator. So if we go to option, statistics, nope, probability, and NCR, so 7C4. Okay, a bit easier to find on the FX 991s, but we get that it's 35. Or you can use Pascal's triangle. 2 to the power 4 is 16. A cubed equals 15,120, and I got rid of the x to the 4s because we don't need that anymore. So a is therefore the cube root of 15,120 divided by 35 times 16. I hope that'll be a nice number. Questions like this, they usually are. So I want the cube root of 15,120 over 35 times 16, and it's 3. And that's the only cube root. Okay, when you cube root a number, there's only one real root. Question 5. The curve with equation y equals 3 times 2 to the x meets the curve with equation y equals 15 minus 2 to the x plus 1 at the point P. Using algebra, find the exact x-coordinate of P. Okay, so we're going to solve this simultaneously, and we only want the x-coordinate, so I don't actually have to feed it back in to find y, which is good. So I've got 3 times 2 to the x. That's going to equal 15 minus 2 times, 2 to the x plus 1. But 2 to the x plus 1 is actually just the same as 2 times 2 to the x, which is what I started to say a minute ago. Add that on. So I've got 3 of this thing. Adding 2 more of that thing gives me 5 of that thing. Divide both sides by 5. 3. And then I get x is therefore the log to the base 2 of 3. They should accept that as an answer. Let me just check. They might want a log 10 base, but that is a correct answer. So, yeah, log to the base 2 of 3. If they wanted something else for the base, like ln or log to the base 10, then we could say that's x times log of 2 equals log of 3, which is using log law. So if I log that and then bring the x down as a multiplier, and then I can say x is equal to log of 3 over log of 2. And that log can be any base. I've just used base e. But that would be an alternative answer. But that just looks a bit neater, I think. Question 6. The circle C has centre A with coordinates 7, 5. The line L with equation y equals 2x plus 1 is a tangent to C at the point P, as shown in figure 3. Show that an equation of the line PA is 2y plus x equals 17. Okay, so we don't know the coordinates of P, but we can probably figure that out shortly. The radius, which is PA, meets the tangent, which we're told is L, at a 90-degree angle. Okay, that's a circle theorem from GCSE. So we know that's a 90-degree angle, which means the gradient of this line is going to be the negative reciprocal of the gradient of L. Okay. So the gradient of L, that is 2. That implies the gradient of AP is minus a half. We also know that it goes through the point 7,5. So the line AP goes through A, by definition. So therefore we know that y minus 5, okay, the y coordinate, is equal to m, which we just calculated as minus a half, times x minus 7, which is the x coordinate. And rearrange that, we should come out to this. Just be careful because it is a show that question, so the answer is in the question. So we get y equals minus a half x plus 7 halves plus 5. Times it by 2, so 2y equals minus x plus 17, and then we can just add x to both sides, and therefore 2y plus x equals 17 as required. Job done. Find an equation for C. Okay, so for C, we need to know the radius. We already got the centre, so we don't have to fuck around with that, but we need the radius of the circle to then state the equation. So I'm going to find where this where this radius intersects the tangent. Okay, and that will be a point on the circle. So I'm going to find the coordinates of P. So 2y plus x is 17, but also the tangent is y equals 2x plus 1. So I'm going to say 2 into 2x plus 1 plus x equals 17. So that's me plugging in this definition of y equals 2x plus 1, into here. So this gives me a linear equation in x. So 4x plus x is 5x equals, that's going to be 17 minus 2, so it's 15. So x is 3, and then I can plug that back into one of those two to find y. And this one's probably slightly easier. 2 times 3 plus 1 is 7. So y is 7. Just double check that with the other equation. 2 times 7 is 14, plus 3 is 17, so it does satisfy that, which is good. So 3, 7 then is the coordinate of P. I can use that in conjunction with the coordinate of A, which is given in the question, to calculate the radius. So the radius then is going to be equal to the square root of the difference in the x values, which is 7 minus 3 squared, plus the difference in the y values, which is 7 minus 5 squared. It doesn't matter which order you do it in because you're squaring them. So that's 16 plus 4 is root 20, which you should then really write as 2 root 5, but we're not going to do that because we want the square of it. So the equation of the circle then is x minus the x coordinate of the centre squared plus y minus the y coordinate of the centre squared equals r squared, which is 20. And there we go. That's the equation of the circle. The line with the equation y equals 2x plus k, where k is not 1, is also a tangent to C. Okay, so this is going to be parallel to the line L, because they both have the same gradient, different k values. So the other tangent, which is parallel to L, is going to be down here. Find the value of the constant k. Well, there's a couple ways we can do this. We could run this through the equation of the circle, set the determinant of that quadratic to be 0. That'll give us a quadratic in k, which when we solve it, one is going to be a solution because of this one, but then the other one will give another answer. An alternative way to solve it is to think, well, okay, well, what does this line go through? We know that this is the point 0.75. We've calculated that P was the point 0.37. So therefore, this point here, well, it's the other side of the circle. So therefore, the centre of the circle is the midpoint. So to get from 3 to 7, we add 4. So therefore, add 4 to 7 to get 11. And then to get to 7 to 5, we subtract 2. So therefore, to get from 5 to the y coordinate, we subtract 2. So it's 3. So this point here is 11, 3. So we know that the equation of the line y equals 2x plus k must go through the point 11, 3. So we can use that to calculate k. So that tells us that 3 is equal to 22 plus k. That tells us that k is minus 19. Therefore, y equals 2x minus 19. That's it. Okay, again, I'll just check that that is indeed the answer to the question. Yes. Question 7. Given that k is a positive integer, show that the integral from k to 3k of that thing is independent of k. Okay, so we're going to integrate this. This is a situation where the top is almost a differential of the bottom. So let's make it a differential and then we can log it. So for part A, I'm going to say this is equal to 2 times the integral from k to 3k of, 2/3, of 3 divided by 3x minus k dx. And I've done that by pulling the 2 out and putting a 3 in. So correction term is 2/3, because now the top of that fraction is a differential of the bottom, which means the answer is just the log of the bottom. So we get 2/3 times the log, technically of the mod of the bottom, so 3x minus k. And that is evaluated for x values k and 3k. So that equals 2/3 of log, I'm going to get 9k minus k is 8k, minus log is 3k minus k is 2k. Oops, that's a k. And when you subtract logs, you can divide their contents. So that's 2/3 times log of 8k over 2k, which is 2/3 log of 4, no k. So therefore, this integral is independent of k. Okay, it doesn't vary with k. As k changes, the value of the integral remains at 2/3 log 4, or if you like, 4/3 log 2. But you can leave it as 2/3 log 4. And part B show that this is inversely proportional to k. Okay, so part B. I'm going to use a substitution in this case because we've got squared on the bottom. So I'm going to say this is the integral from k to 2k of 2 over u squared, where u is equal to 2x minus k. That means that du by dx is 2, which means that dx is a half du. So get a half in there. And that then, these are x limits, just going to emphasise that. So that's the integral from x equals k up to 2k of 1 over u squared, which is u to the minus 2 du. So add 1 to the power, divide by new power. That's minus u to the minus 1 between x is k and 2k. Okay, again, just emphasising that x is k, because I've not changed the limits from x space to u space. I'm keeping it in x space. You could change the limits using this relationship, but I don't have to. So I'm going to plug this back in. So that's minus 1 over u, which is 2x minus k. And that is between x is k and 2k. So that now is fine because my variable is x. So I don't need to emphasise that these are x limits. And that's minus 1 over 4k minus k is 3k, minus when k is, x is k, so that's going to be 2k minus k, which is 1 over k. So that's minus 1 plus 3 over 3k, which is 2 over 3k, which is inversely proportional to k. Okay, so that proves it, which is something times k to the minus 1. So this integral is inversely proportional to k, as the question suggests. Question 8. A curve C has equation y equals f of x, and we're told f primed, we're told the y-intercept, and we're told x plus 4 is a factor. Find in its simplest form f of x. This is a year 12 question, really. So to get from f prime to f, we need to integrate. So f of x is going to be equal to the integral of f primed of x dx. Add 1 to the power, divide by new power, so that's 2x cubed plus a over 2x squared minus 23x plus a constant of integration. Okay, so that's using this fact, so that's done. The y-intercept of c is minus 12. So when x is 0, y is minus 12, so therefore c is minus 12. So 2x cubed plus a over 2x squared minus 23x minus 12. And we're also told that x plus 4 is a factor. So it's using the factor theorem. We know that x equals minus 4 is a root. Okay, so because it's a root of the equation, then we can plug it in and it should equal 0. So f of minus 4 is going to be minus 4 cubed, which is minus 64 times 2 is minus 128, plus 16 over 2, which is 8a, plus, because minus 23 times minus 4 is 92, minus 12, and we want that to equal 0, and that's now a nice linear equation in A. So therefore A is going to be 128 plus 12 minus 92, all divided by 8. So 128 plus 12 minus 92 over 8 is 6. And that's not quite answered the question because we want f of x in its simplest form. So therefore f of x is equal to 2x cubed plus a on 2, a is 6, that's 3x squared, minus 23x minus 12. I wonder if that wants it factorised. Let's just check that. It does want it factorised. So we know that x plus 4 is a factor, so we can factorise that in, x plus 4. So to get the x cubed term, we must have a 2x squared here. To get the minus 12 at the end, we must have a minus 3 over there. I've got minus 3x, but I want minus 23x, so I need to subtract another 20x. I've got a 4 there, so that must be minus 5x. Check the quadratic term, minus 5x squared plus 8x squared is 3x squared, so that's correct. And then factorise this quadratic, so x plus 4 into 2x x. 1 to be plus and a minus, got to be 3 and a 1. That makes a 6, a 3 and 1, and I want that to minus and plus. There we go. Fully factorised. Okay, question 9. Given that theta is measured in radians, prove from first principles that this statement is true. So differential of cos of theta is negative sine of theta. Okay, so differentiation from first principles says d theta of cos of theta is equal to the limit as h tends to 0 of cos of theta plus h minus cos of theta, all divided by h. Okay, that's the definition from first principles of the gradient. So now we're going to use compound angles here. So we've got theta plus h there. So that's going to be the limit as h goes to 0 of, you're going to have cos theta times sine of h minus, cos of h, minus sine of theta times sine of h. These are given in the formula book, which is great. Minus cos of theta, all divided by h. Now we use small angle formulae, but cos of h is approximately 1 minus h squared on 2, and sine of h is approximately h. Okay, it's using small angle approximations because h is small. In fact, we want h to go to 0, so we want these two substitutions in. So it's going to be the limit as h tends to 0 of cos of theta times cos of h, which is 1 minus h squared on 2, minus sine of theta times h, because that is sine of h, it's h, and then minus cos of theta, and that's all divided by h. That equals the limit as h tends to 0. Cos of theta times 1 minus cos of theta, they cancel out. So I've got minus sine of theta times h minus cos of theta times h squared on 2, all divided by h. And now everything on the top contains a h, so I can cancel that. So that's the limit as h goes to 0 of minus sine of theta minus the cosine of theta h over 2. And now as h goes to 0, that's going to disappear, and that just equals minus sine of theta. There we go. Question number 10. Figure 7 shows a sketch of triangle OAB. The point C is such that OC is 2 times OA. It's vectors. So OC is 2 times OA. So to C, so it's going to be up here, about there-ish. There's my C. And those two vectors are the same. Okay, to get from O to A is the same as to get from A to C. Okay, because OC equals 2OA. The midpoint M is the midpoint of AB. So AB is that line. So there's M. That's the midpoint. The straight line through C and M cuts OB at the point N. So that straight line there. Okay, that's through C and M. Cuts OB, which is this line here, at N. So there's my N. Very useful to be drawing this out as you're reading the question. Given that OA, that should be equals A, and OB equals B, find CM in terms of A and B. Okay, so C to M, that's from here to here in terms of A and B. Okay, so part A, C to M, that's going to equal C to A plus A to M. Okay, so get from here to here, we can go from here to here to here to here. But A to M is a half from A to B. Okay, and that's because M is the midpoint of AB. So if you want to go from A to M, you're going halfway from A to B. But C to A is the same as that, but backwards, so it's minus A. So that's negative A, plus a half. And to get from A to B, we do B minus A. And just simplify that. So to get from C to M, we've got minus A minus a half A is minus 3 halves A and then plus a half b. Okay, that's my answer. Show that O to n equals 2 minus 3/2 lambda times a plus a half lambda times b, where lambda is a scalar constant. Okay, O to n. O to n. So O to n is from here to this point. So what I'm going to do is I'm going to say that O to n is actually O to c plus c to n. And the reason why I'm doing that is because I know what Cm is. In fact, that was the answer to part A. And I know that Cn is parallel to it. So therefore I can just times Cm by an unknown constant lambda. I'm also aware that going from O to C is 2a, which if I look here, I've got a 2 times an a. Okay, everything else in here contains this unknown number, okay, lambda. So that is the route I'm going to take. So part B, to get from O to n, I'm actually going to say it's O to c plus c to n. And I'm going to say O to c plus lambda times c to m. Okay, because Cn is parallel to Cm. But O to c, by definition, is 2a. And lambda times Cm, well, Cm is what I found in part A, which is this thing here. So that's going to be a half b minus 3/2 a. And now if I pull out the a's, I'm going to get 2 minus 3 lambda on 2 times a, and I've got plus a half lambda b. Just check that's what I want. There we go. 2 minus 3/2 lambda a plus a half lambda b. Sorted. Hence prove that on to nb equals 2 to 1. Okay, so that's the ratio. Okay, so we know that this vector here has to be parallel to the vector b. So for part C, we know that O to n, that must be parallel to, so something, times O to b. Okay, O to n must be parallel to O to b, because O, n and b are all on the same line. Well, that equals something times b. Okay, because that's, by definition, that's what OB is. So we want the coefficient of A here to be 0, and that gives us a value for lambda. So this tells us up here that the coefficient of A must equal 0. And if I solve that, okay, times by 2, add the 3 lambda, divide by 3, I get lambda is 4/3. Okay, lambda is 4/3. All right, so plug that back into the definition for ON. Therefore, ON equals a half times 4/3 times B, which is 2/3 of B. Therefore, ON is 2/3 of O to B. Hence, n is 2/3 of the way from O to B. Okay, it's 2/3 of the way. Then we have O to n, n to b is equal to 2/3 to 1/3. Okay, it's got to sum to 1, and then times it by 3, which is 2 to 1. Okay, that's what it wants. Probably don't have to put quite so much detail down, but that does explain why it is 2 to 1. Question 11. Figure 2 shows a sketch of part of the curve with equation y equals log of x squared. The finite region R shown in figure 2 is bounded by the curve, the line with equation x equals 2, the x-axis, and the line with equation x equals 4. The table below shows corresponding values of x and y with the values of y given to 4 decimal places. Use the Trapezium Rule with all the values in the y table to obtain an estimate for the area of R, giving your answer to 3 significant figures. Okay, so the Trapezium Rule is given in the formula book. Here it is, numerical methods. The Trapezium Rule. Here we have the integral of y from a to b with respect to x is approximately this thing. And you're told that h is b minus a over n. So it's just a formula plug, this one. So answer to part A. How many strips have we got? Well, we've got 5 points, so therefore that's 4 strips. Okay, so n is 4. So the integral from 2 to 4 of log of x squared dx is approximately, and it's an approximation because the Trapezium Rule doesn't calculate it exactly, is approximately a half times h, or h is the step width, so we're going in halves in the x direction, so it's a half, times the sum of the first and the last, so 0.4805 plus 1.9218 plus 2 times all the others, 0.8396 plus 1.2069 plus 1.5694, close bracket, and that will give you the approximation. So as I said, it's just a formula plug, nice and straightforward. So quarter times 0.4805 plus 1.9218 plus 2 times, and the sum of the other 3, so 0.8396 plus 1.2069 plus 1.5694, close bracket, equals, I get that it is 2.408525, and the question has specifically said to 3 significant figures, so 2.41 to 3 significant figures. Use algebraic integration to find the exact area of R, giving your answer in the form this thing, where a, b, and c are integers to be found. Okay, so the integral of log x. So if we want to integrate log x, 2 to 4, it's log of x squared, isn't it? X. Now what I'm going to do is I'm going to do it by parts. I'm going to say that u equals log of x squared, which means u primed is 2 times log x divided by x. Okay, so following the chain rule, so the 2 comes down, 2 log x, and then got times by differential log x, which is 1 over x. V primed then is 1, and v is the integral of that, which is x. So therefore this integral is going to be equal to uv, which is x times log x squared between 2 and 4, minus the integral of vu primed, which is 2 log x dx between 2 and 4. And then we've got to use integration by parts again. So u, I'm going to say, is 2 log x, u primed is 2 over x, v primed is 1, and v is x. Plug that through, so I get the integral is x times log of x squared between 2 and 4, minus, and now this is going to be uv, so that's going to be 2x times log x between 2 and 4, minus the integral of vu primed, which is 2 dx between 2 and 4. So that's x times log of x squared minus 2x times log of x plus 2x between 2 and 4. Okay, that's what we've got so far. Now we've got to plug in the upper and lower limit. So that's going to be 4 times log of 4 squared minus 8 times log of 4 plus 8 minus 2 times log of 2 squared minus 4 times log of 2. Minus 4. Okay, we can tidy that up, but don't forget that log 4 is 2 log 2. Okay, log 4 equals 2 log 2, which is important here because it wants it in log 2s. Okay, so we've got to extract all that. So if that's 2 log 2 in there, then I need to square the 2, so that's a 4, so that's a 16. If I squared minus a 2, so that's a 14 times log of 2 squared. The log 2 term I've got 4 of them here, and I'm going to get minus 16 of them there, so that's minus 12 times log 2. And then the number I've got plus 8 minus 4 is plus 4. Okay, so that's the exact value. Let's just check to see if that does make sense. It should be around about 2.4 based on my Trapezium Rule approximation. So 14 log 2 squared minus 12 log 2 plus 4. 2.408, yeah, I'm pretty happy with that. And if you want to check exactly, then we use the integration tool, which is in the other calculator as well. So the integral we are integrating is log of x squared between 2 and 4, and that should be the same decimals, which it is. So that kind of confirms that this is indeed the correct answer. You can't use the calculator to do that because the question wants it exact. So you've got to leave your answer like that. Okay, that's question 11. Question 12. Show that cosec theta minus sine of theta is identical to this thing for all theta except for multiples of 180. Okay, that's because cosec isn't defined at those points. Okay, cool. All right, so what I'm going to do for part A is I'm just going to write the left-hand side as 1 over sine theta minus sine theta. Okay, it's just using the knowledge that cosec is 1 over sine. And then I'm going to make this over a common denominator, so I'm going to times top and bottom of that by sine. Get that? Oh, I need sorry, I need a cable. Back to my phone is dying. Okay, so that's 1 minus sine squared of theta over sine of theta. But 1 minus sine squared is cos squared. So it's cos squared of theta over sine of theta. Well, that is, of course, cos of theta over sine of theta times cos of theta, which is cos of theta times cot of theta. There we go. Job done. Hence or otherwise solve this equation. When it says hence or otherwise, it makes sense to use what's just been given. Okay. So what we're going to do is we are going to replace the left-hand side with the right-hand side. Notice it's got x's here where it had thetas, so just be careful. And we're going to replace this directly. So this equation now becomes cos of x cot of x equals cos of x cot of 3x minus 50. Okay, it's in degrees. Okay, we can divide by cos of x. But when you divide by a variable, you must consider when that variable is 0. Okay, because cos of x equals 0 is a solution to this equation, which wouldn't appear from here. So just be careful. Okay. I can times both sides by tan. If I imagine them as being 1 over tans, I can bring them both up. So we end up with tan of 3x minus 50 equals tan of x between 0 and 180. So this actually only yields a solution that x is 90. Okay, now to solve this one, we could inverse tan both sides, but you've got to be careful with the repetitive nature of tan, because there's going to be multiple solutions. So we're going to get 3x minus 50 equals x. It's an obvious solution, so therefore 2x equals equals 50, so x equals 25. That's an obvious solution, but we're missing some. Because we could add pi somewhere, add 180 somewhere here. This is 1 to 1 in the range 0 to 180, so that's not going to make any difference. If you imagine the tan graph, something like this, we have a vertical asymptote there at 90, and we've got that. But if you imagine the graph of tan of 3x, that's going to be happening 3 times as fast. And also the minus 50 is a translated one. So we're going to get kind of this situation. So we're probably looking for two solutions. I imagine there's one there at 25, and there's probably one here as well. This one might just sneak in between the two, so there might not be one there. So yeah, just be careful with just inverse tanning both sides, because you'll miss solutions if you do that. Okay, now how do we get to this solution? Might take a little bit of thinking, actually. I suppose we could use the compound angle formula and split this out. I feel that's a bit too much though, isn't it? Let's try the x plus pi. Let's see what happens there. So 3x minus 50 equals x plus, well, it's not pi, is it? It's plus 180. So tan repeats every 180 degrees. So we're going to get a plus 180. Subtract the x, add the 50, so we're going to get 2x equals 230, and then divide by 2, so x equals 115 degrees. Okay, that's in range, that's fine. We've also got 3x minus 50 equals x plus 360. I think this will be out of range, so we're going to get 2x equals 410, so x equals 205, so that's out of range, so I don't care about that one. And if I do minus 180, then that's definitely going to be out of range, because that will be negative. So I think those are the only solutions. So to conclude, I've got the solutions: x is 25 degrees, x is 90 degrees, and x is 115 degrees. And I should just check those with the calculator, make sure that they're at least solutions to the equation. So I'm just going to change my calculator mode, if I remember how to do that. Shut up. Angles in degrees. Okay, let's see what happens. So cosec is 1 over sine of, and we had 25, minus sine of 25. And then I'm going to do minus cos of 25 times 1 over tan of 3 times 25 minus 50. Okay, that equals 0, so that's good. So 25 is definitely a solution. We had 90 as well, so let's try that one. Always worth checking answers. Yeah, that's a 0, so that's good. And the third one, we had 115, I think it was. Yep. Okay, that's 0 as well. Good. That confirms that your 3 answers are correct. It doesn't confirm if you missed any. If you have a graphical calculator, then you can check that. So I will do that now. So let's delete that one. So I want 1 over sine of x minus sine of x. And I want cos of x times 1 over tan of 3x plus minus 50. Okay, looking for when these intersect. I also need to change the V window. X, I want to go from 0 to 180, and the Y, let's go from minus 10 to 10. Let's see what happens. Okay, so we've got one solution here. In fact, if you do G solve, you can find the intersects. You've got one solution here at x is 25. We've got one solution here when x is 90, and the next solution is solution there at 115, and that's it. The red curve doesn't intersect the blue at any other points. So yeah, those are the 3 routes. Question 13. Figure 2 shows a sketch of part of the curve with equation y equals x log x, for x is positive. The line L is the normal to C at the point EE, and the region R, shown shaded in figure 2, is bounded by the curve C, the line L, and the x-axis. Show that the exact value of r is ae squared plus b, where a and b are rational numbers to be found. Okay, so first things first, let's calculate the equation of that normal. So at the point EE, so I want dy by dx. So dy by dx, we're going to differentiate this as the product. So this times the differential of that plus that times the differential of this. And we're going to have x times 1 over x is 1 plus log x. So that's the derivative function. And we want that at e, therefore dy by dx at the point P, which is when x is e, is 1 plus 1, which is 2. So the gradient at this point of the curve is 2. So that tells us that the gradient of L is the negative reciprocal, negative half. So the equation of L, therefore, is y minus e is equal to minus a half into x minus e. And that gives us that y equals minus a half x. And then I've got a half e plus another e, so it's plus 3 halves e. Sorry, I'm just going through the mark scheme just to check that I'm doing this right as I go. Minus half x plus 3 halves e, good. Okay, so when it hits the x-axis, that's when y is 0. So this implies that x is going to equal 3e. Okay, great. I also need to know when this is 0, so I need this point here, because that's the beginning of my region, and that's going to occur when y is 0, and y is 0 when either x is 0, or when log x is 0, and log x is 0 when x is 1. So clearly it's not when x is 0. For a start, the curve isn't defined at that point because of the logs. So this point here must be when x is 1. So therefore the area of R is going to be equal to the integral from 1 to e of x times log x dx plus the integral from e to 3e of the normal, which is minus a half x plus 3 halves e dx, which you don't have to do an integral for because at the end of the day that region is just a triangle, so you could just do the height, which is e times that width divided by 2. It's fine. Okay, so this I'm going to stick with the integrals. So for this first one, I need to do integration by parts. This one down here, and when you're doing integration by parts, log x is always u. So u is going to be log x. U primed then is 1 over x. V primed is what's left in the product, and then v then is a half x squared. So therefore I get the area is equal to uv, so that times that, so a half x squared times log x between 1 and e minus the integral between 1 and e of vu prime, so the product of these two. So that is just x on 2 dx. And then I've got to plus the remaining integral, which comes out to be minus a quarter x squared plus 3 halves ex, and that's between e and 3e. Okay, just that integral to go. So that's a half x squared times log x minus, this integrates to a quarter x squared. That's between 1 and e. Can't combine these two square brackets because the limits are different. Plus 3 halves ex minus a quarter x squared between e and 3e. Okay, plug in. So I'm going to get half e squared times log e, but log e is 1, minus a quarter e squared. Plug in 1, that's going to be minus 0, and then minus a quarter. So that's the first square bracket. Plus the second square bracket, so plugging in 3e, we're going to get 9e squared on 2, minus 9e squared on 4. Subtract 3e squared on 2, and then minus e squared on 4. Okay, lots of e squareds. In fact, everything's got an e squared except for that quarter, which is reassuring because that's got a constant in the question. Okay, so the coefficients of E then. Let's go back to my computation mode. So we've got a half, minus a quarter, plus 4.5, minus 2.25, minus 1.5, plus 0.25. Okay, so I think that's the coefficient, which is 1.25, or if you like, 5e squared on 4, and plus the quarter. It says rational numbers to be found, so that's reassuring. And what we can do is we can just check to make sure that's right using the equation, the integral function on the calculator. So I'm just going to plug this number in. So I'm going to get 5e squared over 4 plus a quarter. So that comes out to be that. And I want the integral of x log x. And that was between 1 and e. That's e to the 1. And then I want to add the integral of minus a half x plus 1.5 e between e and 3e. Same number, that's very reassuring. Okay, so that's confirms that the answer is correct, and we can move on with our lives. Question 14. Okay, given that y is this thing, show that dy by dx is this thing, where a is a constant to be found. So this is a quotient, so I'm going to use the quotient rule. And is this the last question? Oh, there's 2 more questions. Okay. All right, so u is x minus 4, which means u primed is 1. V is 2 plus x to the half, which means v primed is a half x to the minus a half. Okay, plug them into the quotient rule formula, which is in the formula book. So we get dy by dx is equal to vu primed, which is 2 plus root x, subtract uv primed, which is x minus 4 times a half x to the minus a half. And that is all divided by v squared, which is 2 plus x to the half squared. Okay. All right, so I need to prove that equals this thing. So there's evidently a lot of cancelling to happen here. Okay, so I'm going to leave the bottom factorised. And I'm going to say this is 2 plus root x minus, now x times half x to the minus a half is actually just a half root x. And then I've got plus, because I'm a half times a half. Sorry, negative times a negative. 4 times a half is 2, so that's 2 over root x. All divided by 2 plus x to the half squared. Okay. Okay, let's times top and bottom by root x. So I get 2 root x. That will become an x, that will become a half x. So an x minus a half x is positive half x, but actually when times it by 2 root x. So I get plus root, plus x. And then that becomes plus 4. That is all divided by, times it by 2 root x, and I get 2 plus x to the half squared. So what I'm doing here is I'm timesing it by 2 root x divided by 2 root x. Okay, so I'm timesing it by the number 1, so I'm not changing the fraction, but in doing so I get rid of the fractions in fractions. Okay, this factorises quite nicely, and I can tell that because of the x, the 4 root x and the 4. It's kind of akin to a squared plus 4a plus 4, which is just a plus 2 squared, which is good because it kind of relates to that, but a is root x. So the top factorises to 2 plus root x squared, that becomes 2 root x, and I've still got the 2 plus root x squared on the bottom as well, and those two cancel, and we're left with 1 over 2 root x. Therefore, a is 2. That's just the question. Okay, question 15. Big trick question. Express 2 cos theta minus sine theta in the form r cos theta plus alpha, where r is positive and alpha lies between pi 0 and pi on 2. Give the exact value of r and the value of alpha in radians to 3dp. Okay, so part A. R cos of theta plus alpha is identical to r cos theta cos alpha minus r sine theta sine alpha. Quick calculation to get r is to use essentially Pythagoras, so we get 2 squared plus minus 1 squared all square rooted. So that gives me root 5, and I've taken the positive root because r is positive. And then I can look at equating the coefficients. So the coefficient of cosine is root 5 cos alpha, and that equals 2, which is the coefficient of cosine over here. And that leads me to say that alpha is, making sure my calculator is in the right mode, because I'm aware I changed it. Radians. So I get the inverse cosine of 2 divided by the square root of 5. Oops. 0.464, I think it wants to radians to 3 decimal places, yeah, so 464. And that's R. Okay, so therefore 2 cos of theta minus sine of theta is equal to root 5 times the cosine of theta plus 0.464. Okay, pretty much that. This is rounded to 3dp. Okay, figure 6 shows the cross-section of a water wheel. The wheel is free to rotate around a fixed axis through the point C, right in the middle there. The point P is at one end of the paddles of the wheel, as shown in figure 6. The water level is assumed to be horizontal and at a constant height. The vertical height, h meters of P above the water level, is modelled by this equation. So as it goes round, the height of P is going to vary, dipping slightly below the water and coming back up again. Where T is the time in seconds after the wheel starts rotating. Using the model, find the maximum height of P above the water level and the value of T when this maximum height first occurs, giving your answer to 1 decimal place. Okay, so for part B, the value of T for which is maximum occurs. So the maximum, now the maximum of this is 2 root 5, because if we consider that this is actually just double that in terms of the coefficients of cos and sine, and also theta is now 0.5t. Okay, so we could say that this is 2 root 5 into the cosine of 0.5t plus 0.464. Okay, so that's what this trig bit equals. So the maximum value of this is 2 root 5 because the maximum value of the cosine is 1. Okay, so this cosine is maximum value is 1, so therefore this is 2 root 5, and add the 3. So the maximum height above the water is when h is 3 plus 2 root 5. And we want, for part 2, to find the time that this first occurs. So what we're going to do is we're going to set cosine of 0.5t plus 0.464 to equal 1. And we want to find the smallest positive value of t for which that is true. Okay, think of the cosine graph. It starts there and comes down. Okay, it's the cosine graph. But adding something is going to translate it to the left. So actually the first value of t is going to occur quite a bit later. So it starts on the way down by the looks of it. So I get 0.5t plus 0.464 is equal to 0, but that would give a negative value of t, which we don't want. So the next one is 2 pi, and we can calculate what t is from that. So we're going to have 2 pi minus 0.464. I know that's rounded, but they'll accept any calculation with this figure because of the wording of part A, divided by 0.5. So I get 11.64. And does it request? Yes, it says to one decimal place, so that's 11.6 to 1 dp. And what's the unit? Meters. Nope. Time. Seconds. Seconds. 11.6 seconds. Okay. Let's see. In a single revolution of the wheel, P is below the water for a total of t seconds. According to the model, find the value of t, giving you answers to 3 significant figures. Solutions based entirely on calculator technology are not acceptable. Okay, so part C, we want to calculate when 2√5 times the cosine of 0.5t plus 0.464 is equal to -3. Okay. In other words, h is 0. And there'll be 2 values of t for which this is true, and we want to do the biggest, subtract the smallest. So 0.5t plus 0.464 is going to equal arc cos of -3 over 2√5. That's clearly going to be a negative number, so I want to add 2 pi to that to give me a solution in the positive numbers. And then I can calculate t from that. Oh no, that wouldn't give me negative because it's arc cos. That's fine. Okay, so inverse cos of -3 over 2√5. You subtract 0.464, and then I need to divide that by 0.5. So I get 3.68422155.9, blah, 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 blah. And the other value of t, well, when I do the arc cos bit, I need to do 2 pi minus that instead. So going back up here, instead of the inverse cos, I would have 2 pi minus that inverse cos, and that gives me 7. So that's T1. T2 is 7.026149055. Blah blah blah. So therefore T, capital T, that's the difference between those 2 numbers. So I'm just going to subtract 3.68422155.9 gives me 3.3419 to 3 sig fig. So 3.34 to 3 significant figures. Should probably be checking these answers as I go, because it's very easy to make an error on these questions. 3.34, yes, good. All right, and finally part D. In reality, the water level may not be a constant height. Explain how the equation of the model should be refined to take this into account. So the 3 here would represent the water level. So that's essentially saying that the centre of the circle is 3 meters above the water line, and that's a constant. So maybe the 3 needs to vary. The 3 needs to vary with time. Okay, so that this centre moves up and down relative to the water level. Okay, and final question. Oh, a nice short one. Express y as a function of x of this exponential. Okay, so y I can see is right in there. So what I'm going to do is, first of all, going to put the bases being the same. So that's 2 to the x times 2 squared to the y, which is 2 to the x times 2 to the 2y. And that equals 2 to the power of minus 1.5. Because that is 2 to the minus 1 times 2 to the minus a half. which means that 2 to the x plus 2y equals 2 to the minus 1.5. And then log base 2 both sides, I'll get x plus 2y equals minus 1.5. And then it wants me to make y the subject, so y is a function of x. So subtract the x, divide by 2, and I'm done. Y equals minus 3/4 minus x over 2. And there we go. Sorted. Again, just check the answer to that. Minus a half x minus 3/4. Perfect. Right, so that is the mock paper Jan 13, 2022. Jan 13? No, March 2022. If you have any questions on that, then please come and speak to me.